Alright, today I'll be introducing a very important concept called the concept of axioms. See, axioms are very important in many branches of study. For example, mathematics, for example, science, or even philosophy. Alright, the concept of axioms run very close to these three branches or even other branches of study. But today we'll be talking about axioms with respect to mathematics. Alright, we'll talk about axioms in science, mainly physics, and axioms in philosophy in some other class or some other day. Alright, now see, axioms. What are axioms? Axioms are fundamental statements that are taken to be true. Alright, what are axioms? Axioms are fundamental statements that are taken to be true. What does this mean? It means that axiom and this axiom or this statement or anything that is related to axiom cannot be proved to be true. It is already taken to be true. Alright, we don't prove an axiom to be true, we take that axiom to be true. We don't prove that axiom to be true, we take that axiom to be true. Axiom is like a reference point from which all other things are measured to be true or to be false. All other things or all other theorems are said to be true or said to be false with respect to the axiom that we take. Alright, axioms are like the fundamental building blocks of mathematics. Alright, they are the foundation of any mathematics branch on which the whole theorems and concepts of mathematics are standing or built upon. Alright, suppose this is a branch of mathematics. Alright, at its very foundation is the axiom that we take to be true. We'll understand this with some examples. Alright, first example, set. What is a set? Collection of well defined objects here. The axiom is this statement, collection of well defined object, and every collection will be judged upon this parameter to be called a set or to be not called a set. Alright, how can we say if a collection is a set or not? We will judge that collection or that thing by this definition, collection of well-defined objects. Alright, what does well-defined mean? Well-defined means that if there is any object, then either that object lies in that set or it doesn't lie in that set. Alright, it means that set is objective and not subjective. Alright, set is objective and not subjective. It means that the set, the collection of that well-defined objects will be same for every person, and it will not, the members of the set will not vary depending upon the person who sees that set. Let me give you an example. See, suppose this is a classroom, alright, and in this classroom there are 1 2 3 4 5 girls and 1 2 3 4 5 6 7 boys. Alright, in this classroom there are 5 girls and 7 boys. Now the collection of all girls is a set. Why? Because this collection is well defined. There is no confusion whether to, if a student is a girl or a boy. Alright, so if a student is a girl, then that student will come in this set, collection of all girls. And suppose if a student is not a girl, then this student is not in this set. Alright, so well defined. But see, now suppose if I say collection of all tall boys. Alright, collection of all tall boys. This term is very confusing. Alright, this is not a well-defined term. This is not a well-defined term. Suppose if we take a boy, alright, how do we say, how do we judge this boy on this parameter? How do we say if a boy is tall or short? Alright, height is a very subjective matter. Suppose I can say that 5'6" is tall, but another person may disagree. So height becomes a subjective matter. Alright, that's why this collection of all tall boys is not a set. Whereas collection of all girls is a set, because this set is objective. For me, this girl is a girl, and for any other person this girl will still be a girl. Alright, whereas on the matter of height, opinions may vary. So this collection is not objective, it is subjective. Subjective meaning it is not well defined. Therefore collection of all tall boys is not a set. I'll give you another example. Alright, I'll give you another example. Suppose you are standing here and someone asks you, what is your distance? Can you answer this? Can you provide an answer for this? Think about it. See, this question is incomplete. Alright, this question is incomplete. Why? What is your distance? You're standing here. Distance from what? Alright, distance from what? Distance from whom? Alright, suppose if I ask you what is your distance from me, and I'm standing right here. Alright, then this question is complete. Now you will say this is my distance from you to me. Exactly speaking, this is the displacement, but we'll say distance. Alright, distance from me to you. Alright, so see, for defining your position, you need some other position. It means that you cannot define your position independently. You cannot define your position independently. You can only define your position with respect to some another position. Alright. So in a graph paper, this is the y-axis, this is the x-axis. This graph is showing a two-dimensional space. In a graph, you define all distances with respect to this point called the O or origin. Alright, you define every position in a graph from the origin. Alright, see, so in a way you can say that origin somehow explains the concept of axioms. Origin of a graph somehow explains the position of axioms. Alright, see, you can take any point as origin. Alright, you cannot question the legitimacy of the origin independently. Alright, you can take any point as the origin, but this origin defines the position of every other point. Similar is the concept of axiom. You cannot say that you cannot prove, or you cannot say that if an axiom is true or a false, you assume the axiom to be true. Alright, but based on this assumption that the axiom is true, you test the truthfulness of every other theorem. Alright, with respect to this axiom, whether a theorem or a statement is true or false will depend on this axiom, will depend on the truthfulness of this axiom. Axioms are also somehow, you can take the concept of axiom and you can convert it into frame of reference.